Today, what we're going to do is we're going to introduce production into the mix, and we're going to get into this concept known as comparative advantage. And comparative advantage is another one of those principles which is not immediately intuitive. And I'm going to explain to you why there is little intuition about it and why it is a kind of a difficult to comprehend principle or concept. Now, I'm going to start out by saying that a lot of folks have suggested today that comparative advantage isn't relevant anymore. And they look at the economics presentation of this and the models and they say, oh, well, this is from an outdated time. It was something that was developed hundreds of years ago, and it doesn't really apply in today's world. Well, my contention would be statements like that are coming from folks who don't understand the economic models particularly well. And they're looking at the models and saying, oh, well, some of the assumptions are not satisfied, so therefore I don't believe the model and I don't trust it. Again, what I'll try to relate to you is that these models are helpful to us, but they don't give us the final answer to everything. And that's where we have to learn how to interpret the models, understand their strengths, understand their weaknesses, and then we can apply them more effectively to the world around us. Okay, so let's get started with this new topic, production and comparative advantage. Okay, so what we're going to do is, let me start by, again, and I'll try to do this with pretty much every model that I present in this particular class, is start out with a set of the assumptions. So first of all, we're going to begin with the pure exchange model assumption. So we're going to imagine again that there's Smith and Jones, two people, and they have two objects, goods that they can now produce and trade with. They're going to be apples and oranges. We're going to imagine that Smith and Jones have preferences and desires over apples and oranges, that more is better and there's diminishing marginal utility. And so all of those assumptions from the pure exchange model are going to be kept intact as we move forward. The change we're going to make is a subtle one, but it's going to be an important and distinctive one. We're going to change the original assumption that Smith and Jones simply come to the market with apples and oranges. And instead of having an endowment, they will have an endowment, but instead they're going to produce that endowment instead. All right, so they're going to have to go to work. And they're going to have to, and work in this case is going to mean walking through the apple groves and the orange groves and collecting apples and oranges for their individual consumption or for the potential to trade. That's going to represent the production process. So all that's needed in this model to produce apples and oranges is going to be Smith and Jones's own labor. And they're going to devote a particular amount of time to the production of apples and oranges. Okay, now what we're going to make that's different, and this is going to be a key driver of the model, this third bullet point here, is going to be that their production capabilities are going to differ from each other. And this is going to be an important element that's going to actually motivate what is going to be the final result of this model, which is specialization in the comparative advantage good and trade with each other. That outcome will only come about if Smith and Jones have different abilities in producing apples and oranges. And so we're going to begin at the start with that particular assumption. Okay, let's go. Now, the only change we'll really make diagrammatically for an individual's diagram here is, notice we've got a diagram on the right with apples and oranges. Smith is located down, his origin is here at 0, 0. But we've got a blue line that's drawn in here. And that blue line corresponds to Smith's, this is called Smith's Production Possibility Frontier, or PPF, the blue line. And what we're going to do in the next 15, 20, 30 minutes or so is we're going to talk a lot about that particular blue line. And in talking about it, we're going to introduce a series of economic principles or concepts which have to be defined in order for us to talk more intelligently about the production process that we're describing here. Now, the production process is really, in a nutshell, very simple. We're going to imagine first up here that Smith is endowed with 1 hour of labor. So rather than giving Smith 10 oranges at the outset, we're going to give Smith an hour of labor to work with. And that hour is just a made-up number. It could be 10 hours or 8 hours for a working day. It could be a week. It could be a month. In the problems that I present to you in problem sets and so forth, it will be important for you to look for what the units of measurement are with respect to the time spent in the production process. Because certain factors like labor productivity, for example, which we're going to define next, is going to be dependent on what units of measure we're actually applying in the problem. So the units here is hours of labor, and we're giving Smith 1 hour to work with. Now, I'm going to make up some values here. And we could present this generally, but I'm going to do it with a numerical example because it will be easier to keep track of. Okay, so the numerical example is such. We're going to start out by imagining that if Smith takes his 1 hour of labor and he devotes it entirely to orange production, that he can produce 10 oranges. All right, and we're going to plot that on the diagram right here. It's going to be the endpoint of this blue line right down here. That's 10 oranges and 0 apples, which is what he would obtain if he took his 1 hour of labor and just devoted it to orange production. Okay, end of story there, simple. Next, let's assume instead, alternatively, that he takes his 1 hour of labor and he devotes his attention only to collecting apples or producing apples during that hour. Well, let's imagine that he can get a total of 3 apples if he produces nothing but apples during an hour. Okay, well, that's going to mean, if we go onto his graph over here on the right, that he can produce 3 apples and 0 oranges if he takes his 1 hour of labor and devotes it entirely to apple production. Now you might wonder, well, why is it different, and why can he, I can collect more than 3 apples in an hour? This seems absurd. The numbers or the values don't matter. If I wanted to make this more realistic, maybe I would make it 100 oranges and 30 apples, or even larger numbers. But we'll just keep the numbers small, and it'll make it easier to work with, okay? So those are the 2 endpoints in production, but notice there's a blue line here connecting the 2 red dots, and what that blue line corresponds to are all of the other combinations of apples and oranges that Smith could potentially produce if he divided his time. Suppose, for example, that he's devoted a half an hour of production to oranges. He would get half of 10, which is 5, and let's say he took the other half hour and he spent that time in the apple orchard, in which case he could collect 1.5 apples. Yes, we'll allow half of units of production to take place, and he would get to this point on the blue line right there, right? All right, so he could divide up his hour however he wants. 15 minutes in one good, 45 minutes in the other good, or vice versa. And by doing so, he's going to move his production up and down along this blue line. So the blue line represents Smith's production possibility frontier. Okay, easy enough. Let's introduce some terminology to this mix so that we can talk about it more intelligently. All right, the first term that I want to define is productivity. Okay, so this term up here is prod is going to be a short for productivity. And I could have used just one variable name, like I could have used the letter S, for example, and said, let's let S represent productivity. But I decided to write it out. I don't want to use just P because that could mean prices. I don't want to use PR because that might mean prices. So I just threw out 4 letters and said prod. Let's call prod the productivity. And notice that I've got a subscript and a superscript here. The superscript is an S, and that's going to refer to Smith, because we're going to want to distinguish Smith's productivity from Jones's productivity later on. And then the O down below here, the subscript, is referring to oranges. So when I write prod SO, what I am referring to is Smith's productivity with respect to oranges. And that's going to be distinguished then from the next one, which is going to be Smith's productivity with respect to apples. Now, don't worry too much about whether you threw that extra variable indicator in the subscript or the superscript. It really doesn't matter where you put it. We just put them in different places to keep track of variables connected to particular individuals, individual countries, or individual or specific products. And we're going to need that notation to keep track of things. All right, definition. The productivity for Smith and oranges is going to be measured in general this way. It's the number of oranges that can be produced with an hour's worth of labor. Now, it doesn't mean that he's actually going to use an hour of labor, but if he did use an hour of labor in the production process, how many oranges he gets is defined as his productivity. Well, we've got the values for that. He can produce 10 oranges in 1 hour of work, and so that's going to give a productivity for Smith of 10 oranges per hour, right? And that's how we define his productivity there. Now, take note that his productivity does not vary over the number of oranges that he produces. It might, and we're going to talk about how that might vary later on. We're going to make it a little bit more complicated. But for now, whether he's spending a half an hour producing oranges or an hour or 10 hours by chance, his productivity is always going to be 10 oranges per hour. We're going to consider that an exogenous variable. I'll sometimes use that term, which means it's a variable given to us from outside. It's determined by nature or by Smith's abilities itself, and we're not going to quarrel with how that number comes about. The next definition, productivity of Smith and apples. Same idea. It's just we put the number of apples that he can produce with an hour of labor. That works out to be 3 in 1 hour, and so his productivity in apples is going to be listed here as 3 apples per hour. Okay, that's the definition of productivity. More specifically, it's not just productivity. There's a number of different measures economists use for productivity, but this is labor productivity. So it's how much can be produced with a unit of labor. Now, we've got productivity defined. We can produce or create what's called a production function. That's the next step here. Now, in the production function, we're going to use the variable Q. And Q refers to the quantity produced. So we're using Q as quantity. And we're going to use Q in a variety of ways, but not just quantity produced. We're going to use quantity demanded later on, and we're going to have to distinguish one from the other. We don't need to do that right now. So Q is quantity. Again, I've got an S superscript and an O subscript, and the S refers to Smith and the O refers to oranges. So we're asking the question, what is the quantity of oranges that Smith can produce? Well, that's going to be dependent on two different variables. It's going to be dependent on his productivity right here for oranges, and we're going to have to multiply that productivity. This is a times. We're going to multiply that by this variable here, and that variable refers to the amount of labor, L, that Smith devotes to orange production, O. So again, we've got a superscript and a subscript referring to the individual and to the product. L refers to number of hours of labor devoted to orange production. So we could plug numbers in, for example. If his productivity is 10 oranges per hour, as it is above, and he produces or uses 1 hour of labor in the production process, he can produce 10 oranges. But we could go further. We could say, what if his productivity is 10 oranges per hour, and he has 2 hours of labor? Well, that would be spending 2 days maybe producing. The production function is going to tell you what the value is. It's now going to be able to get 20 oranges out of that. And notice that when we take oranges per hour here and we multiply it by hours, the hours are going to cancel out and we're left with units of oranges. So we're going to have to keep track of units of things. And when we multiply or add things together, we're going to have to make sure that we're adding variables of like units. And if we're multiplying things together, we're going to have to rearrange the unit that we're using in each of those variables. And we're going to have to simplify them to their final conclusion. So we end up with 10 oranges out of that. All right. Next step, quantity of apples produced by Smith. Same idea. It's the productivity of apples times the amount of labor that Smith devotes to apple production. Now, here I'm doing the calculation at the midpoint of the PPF. So we plug in 3 apples per hour, which is his productivity. We multiply it by 1/2 hour, half of his time that he's got available to him. And that's going to generate an output of apples of 1.5 apples. All right, so now we've got a production function that's defined very simply and easily using the concepts or the principles of this particular model. Now, for a little bit of a complication. It is typical for economists to try to think of a problem from a variety of different angles. And sometimes that leads to definitions of new terms or concepts coming out of the original assumptions. Okay, and here's one such thing. We're going to use the term A, and A is coming about, I'm using the variable A because it doesn't relate to anything in the description of the term. It's just commonly used as a variable letter that's used to refer to this thing. It's called the unit labor requirement for oranges. Now, A is the variable name, and we've got a superscript and 2 subscripts. So this would be read as the unit labor requirement for oranges by Smith. Labor is the L, O is the oranges, and S is for Smith. So unit labor requirement for oranges for Smith. And it's defined quite simply this way right here. It's defined as the reciprocal of Smith's productivity for oranges, which we defined up above and is given to us externally in the model, exogenously. All right, so if we have his productivity, we just have to take his productivity and take the reciprocal of it. Notice if we do that, the units are going to simplify or change to 1 divided by oranges per hour in productivity. Well, that's going to be equal or equivalent to the reciprocal of the units, namely hours per orange. So if we plug Smith's productivity from up here into the variable down here, we're going to end up with a unit labor requirement for oranges for Smith equal to 1/10. Okay, so that means it takes him 1/10 of an hour to produce 1 orange. Okay? Takes him 6 minutes and he can collect 1 orange. Pretty slow at doing that. But again, the numbers or values of the number of these productivities don't really matter to us. It's just that we have some variable names and numbers we can use. Now we're going to take all of these definitions of terms and we're actually going to use it to create an equation for the production possibility frontier right here. This is where we're heading. To get to the equation of the PPF, it turns out that that equation is a rewriting of what economists would call the labor constraint in the model. Now, the labor constraint says the following for Smith. It says that the amount of labor that Smith devotes to orange production, this first term up here, plus the amount of labor that he devotes to apple production here, has to be equal in total to capital L, which I'm going to define as his labor endowment. This in the end now, or at the beginning, is what we're giving to Smith. We're giving him previously an hour's worth of labor. And we're saying you can take that hour and you can divide it up as much as you like between orange production and apple production. That's the only two goods you can produce. Okay, well, some total amount of time devoted to the two has to be equal to the total he has available to expend. And we're not going to get into any issues of what if he decides he wants to spend more time. That would change the assumptions of the model and we would have to follow that through. But that's a complication we don't want to get into right now. Let's just give him a fixed amount of labor and let's see what he can do with it. And that's the nature of our exercise going forward. Okay, I plug in here the amount of labor endowment, which is 1. That simplifies it a little bit and puts it in the context of the assumptions I've presented previously. But we're also going to rewrite this labor constraint by substituting for the labor inputs, LOS and LAS. And the way we're going to do that is we're going to use the production functions from above. Remember that QOS is equal to the productivity of Smith and oranges times the amount of labor that Smith devotes to orange production. Okay, and we can rewrite this in the following way. Just move the productivity term over to the left-hand side like this, and we're going to have labor is equal to QOS divided by the productivity of Smith, which is written here. All right, and that's a way of getting some other variables that have to be associated in this way with the amount of labor that Smith devotes to orange production. Take his quantity produced, divided by his productivity, we'll get how many hours of labor he devoted to oranges. But note too that this is 1 divided by the productivity. And 1 divided by the productivity is the unit labor requirement that I just previously defined. Okay, so another way of writing this labor supply of Smith to oranges is that it's his unit labor requirement times the quantity of oranges that Smith produces. Again, we don't know yet how much he's going to produce or where he's going to be on the PPF. We're just looking at hypotheticals. These are the things that are possible. And that's why we call it a production possibility frontier. Because it's not a realization of what's going to happen yet. It's just the different possibilities he can come out with based on the assumptions that we're making. All right, so let's take this. So we're going to take this term and this, and we're going to take it and plug it in to the labor constraint over here. So we're going to substitute for LOS and plug in ALOS times QOS. All right, and that's what gets me to this term in this part of the equation. Okay, but then we do exactly the same thing for apples. We can take the production function for apples, do exactly the same exercise, and we can plug in for the labor supplied to the apple production by Smith and make it equal to ALAS times QAS. All right, and that has to be equal to 1. Now, one last step, given the numerical values that we plugged in for Smith's labor productivity for oranges and apples, we can then derive the unit labor requirements for Smith and oranges, which is 1/10. We can derive the unit labor requirement for Smith and apples, which is going to be 1/3. We can multiply them by the quantities, and by doing so, we get the equation of the production possibility frontier. But we've also got incorporated in there some terminology, some economic concepts like the labor endowment, like unit labor requirements, like productivities and production functions defined in a very, very simple way. So out of this one simple straight line, we get a way of writing the equation. Again, 1/10 quantity of oranges by Smith plus 1/3 quantity of apples by Smith is equal to 1. And let's just verify that that's going to work. So let's suppose we take QAS and make it equal to 0. If that were 0, then QOS is going to be 1/10 times QOS is equal to 1. And that's going to make QOS equal to 10. Okay, so we can rewrite the equation. We plug in different values for the quantities. And what we're going to end up with is that all of the quantities that satisfy that particular equation are going to extend between this endpoint at 10 on the orange axis and this endpoint of 3 on the apple axis. And all of the different quantity combinations are going to be found in the equation of this particular line. And there we have it. Now, Jones. We have another individual out there, Jones. And Jones can also produce apples or oranges. We are going to imagine that Jones's labor endowment is 1 hour of labor, just like Smith's. And we're going to say that Jones's production possibility frontier, and remember, Jones does everything upside down, because we're going to incorporate this into an Edgeworth box diagram in a few minutes. But given that Jones's origin is up here in the upper right, his PPF is listed here, and it's got endpoints given From that information on the graph and the fact that he's producing for 1 hour, you should be able to answer the questions on the right. So I ask all of you, what is Jones's productivity for oranges? Look at the diagram, you should be able to write down the answer. And you're all getting it right because you're looking at the diagram right here on the orange axis and measuring over 1, 2, 3. He can produce 3 oranges in an hour. Okay, so 3. Now the answer is not just 3. If you're asked the question, what is Jones's productivity for oranges? Don't put 3. Put 3 oranges per hour. Use the units also. This is an economics class, not a math class. And that means the units are as important, if not more important, than the actual number in the answer. You've got to know what it is we're measuring and what it is we're reporting. So always remember to put units. Now, there is an exception. There is sometimes I will give you the units in the question itself. And I would say something like, state Jones's productivity in oranges per hour. And then you would write 3, would be fine. So there are some exceptions to that rule, but always be conscious of units. I mentioned that once, and then maybe I'll mention it a few times later, but keep that as an important point going through the course. Okay, next question. Productivity for Jones and apples should be pretty straightforward. 10 apples per hour is the popular response, and indeed, it is 10 apples per hour. Now, unit labor requirement for Jones and oranges. If you got his productivity, you know his unit labor requirement. What is it? Okay, now, most of you are skipping the units, which is fine in a chat room response. But again, on the exam, make sure you put the units down. Some of you have put the units down correctly. I saw 1 or 2 answers that put it in the wrong direction and said oranges per hour, but it's not. It's hours per orange when we take the reciprocal of that. So this is where things start to get a little bit confusing because you got to remember which direction is productivity measured in, which direction is unit labor requirement measured in, and this is something you've got to practice with in order to remember them. Okay, unit labor requirement for Jones and apples, pretty straightforward again. So this one is 1/3 hours per orange. This is 1/10 hours per apple. Now, I'll also point out, sometimes I'm going to give you units for products in a different context, and it might be kilograms of apples, and it might be kilograms of oranges, in which case you're not going to put apples per hour, you're going to put kilograms of apples per hour is going to be the units. So if the problem is defined measuring things in kilograms, then define the units in terms of kilograms. And if you're using kilograms for both apples and oranges, then you need to be a little bit more specific and write 10 kilograms of apples per hour and 3 kilograms of oranges per hour. All right? So be conscious of the units always and always include that. Now, what is the equation of Jones's production possibility frontier? You've got the data in front of you, and you should be able to just write down the equation. That's going to be a little bit harder in the chat room, I think. And yeah, so the equation, again, is going to be 1/3 times the quantity of oranges for Jones plus 1/10 times the quantity of apples for Jones is going to be equal to his endowment, which is going to be equal to 1. And that's the equation of Jones's production possibility frontier. Okay, pretty simple, straightforward. Next, I want to define the following concept, absolute advantage. Now, I've got this written in kind of a obscure way, but what I'm saying here is that somebody has an absolute advantage in the production of some good. We can be very general about it and call the person A and the good X and so forth. But here we're talking about apples and oranges. And so a simpler way to say this is that, for example, Smith has the absolute advantage in the production of oranges if Smith's productivity for oranges, let's write this as O and S, is greater than Jones's productivity for oranges, J and O. Okay, so whoever has the higher productivity in a production of a particular good is going to be said to have the absolute advantage in that particular good. All right, so let's go back to the variables that we defined here for Smith and Jones. Okay, we've got Smith's productivity for oranges listed here. We know it's 10 oranges per hour in the example that I'm putting together. We calculated Jones's productivity for oranges right here. It's 3 oranges per hour. So if we go down to the definition, we know that 10 is indeed greater than 3, skipping the units just for simplicity for the moment. And that means that Smith has the absolute advantage in the production of oranges relative to or compared to Jones. Another way of saying that same thing, kind of in a looser way, is that Smith's better at producing oranges than Jones is. Smith has better technology, we might say. Or maybe he lives closer to the orange groves than Jones does. And so it takes him less time to get there in order to pick and produce the oranges. Whatever it is, Smith has got some advantage in production that makes him more productive than Jones, okay? He's better at producing oranges, and we're going to call that an absolute advantage in production. Now, the second specification down here is the same idea, but it's written in unit labor requirements instead. And I forgot to mention why I think economists have introduced this notion of unit labor requirements. It's largely because sometimes economists want to think not about the output side of the production process, but they want to talk about the cost side. How costly is it in order to produce a particular good? And the unit labor requirement is kind of getting at that, because remember, the units of the unit labor requirement is in hours per orange. And that's telling you how many hours of labor you have to expend. It's a cost. How many hours of labor you have to give up in order to produce an orange. So it's a reflection of the cost of production, measured not in dollar terms now, but in a slightly more complicated way in hours of labor input. All right, now, if we compared the cost of producing oranges for Smith and Jones, we would come up with the following. Smith's unit labor requirement in orange production, remember, is 1/10 hours per orange. And Jones's unit labor requirement for oranges is going to be the reciprocal of his 3, which is going to be 1/3 hours per orange. Now, this gets a little bit more confusing working with fractions, but certainly 1/10 is a lower or smaller number than 1/3. And so we would say that because 1/10 is less than 1/3, for Smith's unit labor requirement is lower than Jones's, that again, Smith has an absolute advantage in the production of oranges. Saying it with unit labor requirements, we're kind of saying Smith has an absolute advantage because he can produce oranges cheaper than Jones can produce them. And cheaper here means using fewer hours of labor expenditure. Now, because unit labor requirements are just reciprocals of productivity, if this relationship is true, it follows mathematically that that has to be true at the same time. So they're equivalent to each other. But now you should begin to see that I can give you information about two individuals in a variety of different ways. I could give you the productivities and then ask you to calculate who has the absolute advantage. Or I could give you the unit labor requirements, virtually equivalent, and you can calculate who has the absolute advantage. Or I can just give you a diagram and an amount of labor that's being used in the production of that particular product. And you should be able to figure out what the productivities are, and thereby figure out what the unit labor requirements are, and thereby figure out even what the equation of the production possibility frontier is. Right, and this is going to become one of the things you're going to have to deal with in answering questions. And that is, I'm going to give you oftentimes partial information. I'm going to give you some of the things, basically everything you need, but it's not all going to be presented right there in front of you. You're going to have to do a few derivations or calculations in order to get to the answer that I'm looking for. And this is going to be a test of whether you can kind of figure out what information you need, put it together in the appropriate way, and come up with an answer to the question that's being addressed or asked, again, in the context of this particular model. And thereby, by virtue of working these problems out, you're going to be able to figure out some of the results that are being derived in the context of this model. You'll see what I mean as you begin to go through the problems. But I have to emphasize, as I have before, you're going to need to work through these problems in order to memorize the definitions of terms and be able to work with these particular concepts in an effective way. If you don't practice them, even if you understand everything that I'm saying today, if you don't practice it, it's not going to be real easy to duplicate and get the answers right quickly. Okay, so that's just a little bit of advice and suggestion going forward. Next concept. All right, we want to introduce the term opportunity cost. And let me just start by talking generally about opportunity cost. The general definition is that opportunity cost is the value of the next best opportunity from doing something. So a lot of times we're faced with choices, and oftentimes we're faced with lots of different choices. I could do X, I could do Y, I could do Z, I could do a whole bunch of things. I could occupy my day with a whole lot of different things. Okay, the thing that I choose to do should be the thing that gives me at the moment the most value. If I'm trying to maximize my welfare and utility, what I do should be, optimal for me, should be best for me. The opportunity cost is going to be, what is the value of the next best thing? In other words, what am I giving up in order to do what I'm doing now? And generally speaking, we think that people should give up the next value of the next best opportunity should be a little bit low. Should be, what you're giving up should not be as valuable as the thing that you're doing now, because if it is, if it's more valuable, then you should be doing that instead. Okay, so in general, that's the opportunity cost. And the way it's often presented in a principles class is to, think of all of you as college students, and all of you who are listening to me right now have chosen to participate in this particular lecture rather than doing something else this morning or this evening, depending on where you're located in the world. And the value that something else is valuable to you. So for those of you on the East Coast listening to me at 10 o'clock in the morning, your next best opportunity may well be sleeping, but you've chosen not to sleep, and instead you've chosen to be at this lecture. So the value of sleep, which might be the thing you'd be doing otherwise, is actually the opportunity cost, what you're giving up in order to be here today. All right, and these examples redound. It goes on in all sorts of different contexts. Now, what we're going to do here is we're going to talk about opportunity cost in the context of production for Smith and Jones. Okay, and that means, it's going to be a little bit less general in terms of its application. But what we're giving Smith and Jones is an opportunity to produce, but they have a choice to make. They have an opportunity to produce apples or oranges or some combination thereof. What we want to learn how to measure in the context of the assumptions of this model is what would, for example, Smith's opportunity cost, OC, for oranges be? So Smith S, O for oranges, OC for opportunity cost. What would be Smith's opportunity cost of producing oranges? Now, the answer to that, or the definition of that in the context of this model, is going to be given by this ratio right here. We're basically asking the question, how many apples does Smith have to give up in order to produce one more orange? So let's go back to his production possibility frontier here. And let's suppose Smith decided one day he was producing right here at 3 apples and 0 oranges. And we asked the question, what if Smith wanted to produce one more orange, namely move in this particular direction? Well, he's producing no oranges right now. If he wanted to produce one orange, what he would have to do is he would have to take some of his time that he was devoting towards apple production, and he'd have to move it over into the production of oranges. The fact that he has to give up apples is what makes it a cost. He can't just produce more oranges and keep the same number of apples as he had, because he doesn't have the time in order to do that according to the model. All right, so if he wants to produce one more orange moving in the rightward direction, he can't unless he gives up this many apples. All right, so one orange, X is the amount of apples he has to give up, so X is equal to the opportunity cost of orange production for Smith. I did it the wrong way. I should put S on the top and O on the bottom, but you get the idea. All right. Now, if you look at that particular diagram here, you'll notice that what I've specified in moving from point A to point B here is I've specified that X divided by 1, which is the same as the rise over the run in moving between points A and B. X is the rise, 1 is the run. And so what we're really looking at in calculating opportunity cost of Smith and oranges is the slope of his production possibility frontier. That slope is giving us exactly the principle or concept that we're looking for, the opportunity cost of orange production. There's one caveat to that statement. It's the first definition I have right here. The opportunity cost of Smith and oranges is the negative of the slope. All right? And that's because the slope of that line actually happens to be a negative slope. And when I talk about opportunity cost in the class, or when we report it, we're not generally going to put the negative sign in front of it. We won't. We'll just write opportunity cost as it's 3 apples per orange, for example, or it's 10, or it's whatever. We're not going to put the negative number in front. And the reason not is because we've already got it noted in the concept itself. It says it's an opportunity cost. We recognize that it's what you have to give up to get something else. So the negativity is incorporated into the name of the variable itself, and so we can write it as a positive value, and we always will. So opportunity cost will be presented as a positive number. There's some other ways calculating or coming up with the slope of Smith's production possibility frontier. If we were to take that equation, remember the equation, ALOS times QOS plus ALAS times QAS is equal to L. If we were to take this, and we've got 2 variables defined here, QO and QA. That's what we're plotting on the graph. We could rewrite this in the form of an equation of a line, y equals mx plus b. I'm not going to do this for you. I'm just going to show you where we're going. And if we did that, remember that the M term here refers to the slope of this particular line that's being reported or recorded here. Well, that slope in the context of this particular model is going to turn out to be exactly this variable if we define the equation in terms of unit labor requirements. So the slope of the production possibility frontier is going to be ALOS, Smith's unit labor requirement in oranges, divided by ALAS. Now, to see why that ratio of terms is going to give us the right units we want. And remember, back up here, the units we want for opportunity cost of oranges is going to be how many apples on the top have to be traded in exchange for how many oranges on the bottom. So the units of opportunity cost is in numbers of apples per numbers of oranges. It's a ratio of units. Remember that. And now things are getting tricky because opportunity cost is measured one way. Unit labor requirements are measured a different way. Productivity is measured a third way. All of these are measured in different ways, and you need to learn what the units are in representing each of these individual concepts. Now, how do we get from a term here, ALOS, which is in units of hours of labor per orange, and we divide that by another term, ALAS, which is in hours of labor per apple? Well, let's look at that. We can take the units and mathematically rearrange them like we would a fraction. Hours of labor divided by oranges, and then we're going to multiply it by the reciprocal of the denominator. Right? So we're going to put apples on top and hours of labor on the bottom. Well, once we do that and line it up in this particular way, the hours of labor are going to cancel out. And we're going to be left with units of numbers of apples per numbers of oranges. So keep that in mind. Remember, start to kind of think of ways to remember. Opportunity cost of oranges measured in apples per orange. Now, third way of measuring opportunity cost of oranges for Smith. Maybe you're not given the unit labor requirements like you would need for this particular equation. Maybe you're given the productivities, or you figured out what the productivities are by looking at the diagram. In that case, you can take the productivities of Smith in apples divided by oranges. And here too, let's go back to the diagram. This diagram, we started out by noting that the endpoint here, 10, is Smith's productivity of oranges because he has an hour worth of labor. This endpoint over here, 3, is Smith's productivity for apples. We can define the 2 points on the line as A and B and measure the rise over run. The rise right here is the productivity of apples for Smith. The run right here is the productivity of oranges for Smith. So if we take the productivity of apples divided by the productivity of oranges, ignore the negativity of the slope, then we've got another way of defining the slope and therefore defining what is the opportunity cost of producing oranges. All right, so now I can give you information in a variety of different ways, and from some of the information, you can figure out the other things that you're going to need to use or derive in order to answer the different questions that might be asked of you. Now, let me bear in mind, this is about the simplest production process that we could possibly imagine. We've only got one input in production, it's work or labor. We've only got two goods that can be produced, apples and oranges. We've only got two people. This is about as simple as it gets in an economy. And yet, note how complex the definitions of different terms are beginning to get. Things can get really complicated really quickly, even when we're working with a very simple set of relationships. And that's one thing that we should learn or begin to appreciate, that simplification in model building is absolutely essential, because when we simplify it even down to its barest basics, it still can be pretty complicated to analyze and to work with. Working in reverse, if we were to say, well, let's forget about all the simplification and assumptions, let's just try to model the world the way it is. Well, if this is so complicated, you can imagine what trying to understand and appreciate what the real world is like would be difficult, if not impossible. Right? And so that's why this is valuable and useful for us. Okay, how about the cost of apples? All I did was define the opportunity cost of oranges, but now if we look at apples, it's going to be the opposite of everything that I just talked about. Opportunity cost of apples is going to be the reciprocal of the opportunity cost of oranges. So in terms of unit labor requirements, you're going to put the apple term on the top. Okay, you're going to put the opportunity cost of apples on the top. Okay, and the opportunity cost, the unit labor requirement of oranges on the bottom. Or you're going to put the productivity of oranges on the top and the productivity of apples on the bottom. Because the units of this thing is going to be in number of oranges per apple. Now, how many oranges have to be given up to produce another apple? Now, it's going to be 1 over the slope of the production possibility frontier in this particular case when we're talking about apples here, but we're talking about the oranges is on the x-axis. And so You got to keep track of kind of what's on the x-axis, what's on the y-axis in terms of whether the slope is going to correspond to which opportunity cost. Let me give you the principle here. If oranges or a good orange is on the horizontal axis, the x-axis, then the slope of the PPF is going to correspond to the opportunity cost for that good, the good that's on the x-axis. Okay, and the opportunity cost of the other good, apples in this case, is going to be 1 divided by the slope of the production possibility curve, F, as represented with oranges on the x-axis. I know what I just said is confusing to me, so it's probably confusing to you too. Okay, new concept, comparative advantage. We're going to say that a person has a comparative advantage in the production of a good, for example, Smith and oranges, if Smith can produce oranges at a lower opportunity cost than Jones. Okay, so we're going to want to look at opportunity costs of the two individuals and compare them with each other. Whoever can produce the good at a lower opportunity cost will be said to have comparative advantage in that particular good. Okay, so we can look at opportunity cost itself and just, if you're given the opportunity cost, you could just compare them. If you're given unit requirements for the individuals in oranges and apples for the two people, then you can construct the ratio of those unit labor requirements corresponding to the slopes of their PPFs and then compare them to each other. Or if you can figure out what the slope of their production possibility frontiers are, take the negative of those, then the one whose negative of the slope is lower than the other ones has the lower opportunity cost and therefore would be said to have the comparative advantage. Okay, so now let's go back to the numbers that we have. Let's go back to Smith's diagram. Let's calculate Smith's opportunity cost. We're going to have to imagine this. So let's calculate Smith's opportunity cost for orange production. It's going to correspond to the slope of his production possibility frontier. What is Smith's opportunity cost for oranges? 3 apples, good try, but not right. 3 apples per 10 oranges, 3/10. The answer is, for Smith, 3/10. So it's the ratio of productivities of apples to oranges. That's the easiest way to do it. Or just look at the slope of his PPF and know that the rise is 3 apples, the run is 10 oranges. And so the answer would be, and I would write it this way, 3/10 apples per orange. Like, don't write 3 apples per 10 oranges, although that's technically correct. It's better when you're going to start to do calculations and work with things to separate the number from the units and not to intersperse them like 3 apples per 10 oranges. So if you wrote 3 apples per 10 oranges, we won't mark you wrong. But if you're going to have to do calculations with these later on and manipulate the units sometimes, it's just easier, I think, to keep track of things if you write 3/10 apples per orange. Just some suggestions or advice there. Okay, so that's Smith's opportunity cost for oranges. Real quick, since we're doing this, what is Smith's opportunity cost for apples? Okay, I see a bunch of answers, and I want to highlight the ones that are incorrect with units. The opportunity cost for apples is indeed going to be the value 10/3 for Smith, but it's going to be in units of oranges per apple. It's going to be the productivity of oranges, 10, divided by the productivity of apples, 3. And so it's going to be in units of oranges per apple. And it's like asking the following. What's the opportunity cost of apples, which means how many oranges does Smith have to give up in order to produce another apple? And the answer to that is moving backwards along the production possibility frontier. The answer is he's going to have to give up 10/3 of an orange in order to produce another apple. All right, a lot of oranges have to be given up to produce apples because he's much more productive in oranges than he is in apples. All right, now let's go to Jones's production possibility frontier. And I ask you the question again, what is now Jones's opportunity cost for orange production? Jones's opportunity cost for orange production. Okay, the answer is going to be 10/3, and it's going to be in units of apples per orange. So 10/3 apples per orange. Now, I've thrown a bunch of stuff at you. We want to compare that, and figuring out who has the comparative advantage, we want to compare Smith's opportunity cost for oranges with Jones's opportunity cost for oranges and find out whose is smaller. And answers you've given, we would find that Smith's opportunity cost for oranges is 3/10 apples per orange, while Jones's opportunity cost for oranges is 10/3, also apples per orange. All right, so now 3/10 is clearly less than 10/3, and so therefore we would say Smith has a comparative advantage in the production of oranges, as well as the absolute advantage. He has both. Now we could also ask the question, what about who has the comparative advantage in apples? To do that, we have to flip those variables around. 3/10 is going to become 10/3 oranges per apple. Jones's 10/3 is going to be 3/10. We flip it around. And if we were to calculate who has the comparative advantage in apples, we would say the following. Again, I wish I could write it down, but my pen has failed me. Okay, the following statement is how we would analyze it. Jones has the comparative advantage in apples because Jones's opportunity cost for apples is 3/10 oranges per apple, which is less than Smith's opportunity cost for apples, which is 10/3 oranges per apple. Now, here's an important point. Take note of the following thing I say. You want to keep track of when I ask you a question like who has the comparative advantage, you might be able to look at a graph, see what the slopes are, and tell me Jones has a comparative advantage in apples. If I ask the question, follow-up question, why, the answer to the question why is always going to be, or almost always going to be, applying the definition of comparative advantage. The why is going to be, show me the opportunity cost of Jones and Smith in apples, and show me why Jones's opportunity cost is lower than Smith's. Or apply one of the other definitions that have been given for opportunity costs and compare them with each other. So you need, the answer to the question why is always going to be, apply the definition of the concept or term that's been given to you in class. And that's how you answered the question. Now, it's going to be a little bit insufficient sometimes for you to just say, Jones' comparative advantage because his opportunity cost is low. Okay, if you're given a graph and you're given numerical values for different things, then the why has to include not just that Jones has a lower opportunity cost, but also show me what Jones's opportunity cost for apples is, and show me how it compares to Smith's opportunity cost for apples, and then show me why Jones's is lower than Smith's. That would be a complete answer to the question, why does Jones have a comparative advantage in the production of apples? All right, so I don't want you to get caught up and think, oh, I just have to say, oh, Jones because he has a lower opportunity cost. Yes, that's a true statement, but it hasn't given me all of the details necessary to know that you know why Jones has the lower opportunity cost in the production of apples. Okay, that makes some sense, I hope. All right, I hope you are all beginning to recognize and realize, if you haven't already, that this is going to require some practice to get used to. I've been teaching this for numerous years, and I still get mixed up sometimes in stating certain things because of the ratios that have to be kept track of and the upside down nature of some of these calculations. And so the best way to get proficient in it is to keep practicing it. And the problems in the problem set number 2 will help you in that particular endeavor. Now, what are we going to do with this? We want to get to this, autarky, production, and the Edgeworth box. To do that, I'm going to go back to Smith's original diagram here. And here's the exercise we're actually going to do. We're going to say, let's suppose, for all, that Smith and Jones are in autarky. Autarky, A-U-T-A-R-K-Y. Autarky means no trade, or you're isolated, you're self-sufficient, you're producing just for yourself. All right, so let's go back to Smith and imagine that he's producing just for himself. He doesn't have the potential to trade with Jones. He doesn't even know Jones exists. But we know that he can produce anywhere along the blue line corresponding to his production possibility frontier. All right, well, the next question we might ask is, what would Smith produce? If he can produce anywhere from 3 apples to 10 oranges and any combination between those 2 endpoints, what would he actually produce? Well, here we need to throw in some additional assumptions like we made before in the pure exchange model. First of all, let's imagine Smith is interested in maximizing his utility. That's the best way forward, because that's going to give us a unique answer to this particular question. All right, if he's maximizing his utility and he's got indifference curves representing his preferences, and his preferences have the assumptions of more is better than less and diminishing marginal utility, then his indifference curve is going to look much like the red line that's drawn on the diagram here. Now, we can take, that's just one of the representative indifference curves, but he's got a whole bunch of indifference curves that could be drawn. All right, all I can do is to highlight now and talk through it. The indifference curve that's shown is tangent to the production possibility at one particular point. And I happened to draw this one so that it was tangent at exactly the midpoint. I didn't have to do that. I just did it for convenience. So again, it would be easier for us to talk about. If it's at the midpoint, we know that at that point, Smith would be producing 5 oranges and 1.5 apples. We can also look at that indifference curve though. And if you imagine a lower one, one that's just a little bit closer to the origin for Smith, then you'll notice that it's going to cross the production possibility frontier in two places, a little bit to the left of that one that's drawn and a little bit to the right of the one that's drawn. But if it's a lower one, we also know that that has to give Smith a lower level of utility. So any lower indifference curve is going to cross and at any of the points to the left of the black dot and at all of the points to the right of the black dot. Different indifference curves will pass through those points, but all of those indifference curves will be lower than the one drawn. And so that means if Smith really wanted to maximize his utility, he would move up and down his production possibility frontier until he found a point that was just touching one of his indifference curves, the highest one possible. And that would be the way to maximize his utility. All right, so let's assume Smith's indifference curve looks like the red line. Let's assume it's tangent at the point in the midpoint, and that would be the point that Smith would choose if he were isolated and by himself, producing apples and oranges just for himself. Next, Jones. Jones has got preferences over apples and oranges too, and I'm just gonna, again, for convenience, imagine that Jones's indifference curve is just tangent to his PPF, which is very different than Smith's, but it's tangent to his PPF also at the midpoint. Again, just a coincidence, I just drew it that way for convenience. But if it is, then Jones would maximize his utility by producing 5 apples and 1.5 oranges, and he would be on the midpoint of his production possibility frontier. Okay, now the next question I'd ask is, suppose Smith and Jones go off during the morning, they spend their hour collecting their usual collection of apples and oranges, and then they come back and they wander through the fields and they meet upon each other one day. They happen to run into each other. And Jones is carrying 5 apples and 1.5 oranges, and Smith is carrying 5 oranges and 1.5 apples. And they begin a conversation and talk about what they do and the products that they have, and they talk about the potential for trade. We might then ask, would Smith and Jones coming to the market with an endowment that has a little bit of apples and oranges and which is maximizing their utility initially, would they have any incentive to trade with each other, given that particular starting point? Now, I would argue that if we don't know what these diagrams look like, if we don't have the ability to construct an Edgeworth box and to see visually, I think we wouldn't be able to answer that question very intelligently. We wouldn't know for sure whether they would be better off trading or not. But because we've learned how to create an Edgeworth box, we can actually do that. And what we've done here is we have, again, superimposed now what is the endowment for Smith and Jones, which happens to be on the midpoint of their individual production possibility frontiers. And we take those midpoint values and we put them on top of each other to create the Edgeworth box. Now you'll notice that this particular Edgeworth box is such that the dimensions of it are 6.5 long by 6.5 apples high. And the reason it's 6.5 by 6.5 is because Smith's coming to the market with 5 oranges. Jones is coming to the market with 1.5 oranges. The sum of that is 6.5 oranges. Likewise with apples. Jones comes to the market with 5 apples. Smith with 1.5 apples. The sum total is 6.5 apples. So the Edgeworth box dimensions is 6.5 by 6.5. The intersection of their PPFs, the endowment, is now in the middle. It's not at the end point, and that's okay. But notice that because each of them are maximizing their utility originally, the point on their PPF happens to be just where an indifference curve is tangent. And that means when we superimpose their PPFs on top of each other, like we're seeing here, you'll see that a lens is created between the red and the blue indifference curves, right? And that means if Smith and Jones were to trade upward and to the left into the lens, Smith giving up some of his oranges in exchange for some of Jones's apples, maybe 1 for 1 or 1.5 for 1.5, they would end up somewhere in the middle of the lens. And therefore, we can see that both of them would be made better off as a result of that particular arrangement. So trade would certainly be possible for them and would be mutually advantageous in this particular situation. All right, and that's the first depiction we have, sort of an autarky, come together, realize that trade could be beneficial, and maybe make an exchange. Smith and Jones, let's say, trade 1.5 apples for 1.5 oranges, or 1 for 1, and they end up in the lens. They both go home happier than when they did before. Now, that's not any different than the story that we told before, okay? They've just come to the market with a different endowment. There was still a lens. They can trade and become better off. That is the story we told in the Edgeworth box pure exchange model story. We want to go a step further next, okay? And I'm going to do that. I'm going to do that really quickly, and then we're going to come back and revisit this point next time in class. All right, this is what I just said. But suppose Smith goes home and he reflects upon the trade that he made with Jones that particular day. And he says, you know what? I just traded with Jones 1 apple for 1 orange. PO over PA, my terms of trade, was 1 for 1. Right? And we were both better off. I was better off as a result of that. I'm Smith. I don't care about Jones. I just care about myself. But I was better off as a result of that. Now, Smith knows full well his production capabilities because he's been collecting apples and oranges for a long period of time, and he knows how much of one good he has to give up in production to get more of another. In other words, he knows that his opportunity cost is 3/10 of an apple to produce another orange. Now, what Smith might do in this particular situation is to comparison. So at night, he's sitting there reflecting on the trade, and he's saying, wait a minute, price that I get in the market with Jones happens to be 1 apple for 1 orange. But my cost of producing another orange is only 3/10 of an apple. So in other words, in production, I have to give up 3/10 of an apple to get 1 more orange. But I can take that orange, it seems, and go to the market, and I can get 1 apple for that orange. So if the price is greater than the cost of production, it's profitable for Smith to think, hey, I should produce more oranges. And if I could do that and come back to the market next week or tomorrow with more oranges and trade them 1 for 1, then I'm going to make a profit. I'm going to make more money. All right, now, next time, we're going to imagine what happens if Smith behaves that way. And Jones is going to end up doing much the same thing. All right, and Jones is going to think similarly to produce more apples. And so what this is going to lead them to is profit seeking, I'm going to suggest, is actually going to lead them to specialize in the good in which they have a comparative advantage. And we're going to see what the implications of that will be next time. Okay, in this particular case, when we superimpose their endowment points, which is the midpoints of their PPFs, we can see that because they're maximizing utility, that their indifference curves have to cross each other and create a lens. And this lens right in here is an area to which they can trade into. And as a result of that, we know from the Edgeworth, from the pure exchange model, that they're both going to become better off as a result of that trade. Okay, and so we can see visually now all the assumptions incorporated into this diagram, and we can see that given those assumptions, given that they're self-interest motivated, that they would have an incentive and the possibility to trade with each other and make themselves both better off. Okay, but as I said at the end of class last time, this is no different than the result we got in the pure exchange model. And so what happens next is where things get a little bit different. Okay, and I finished up last time with this table, I think, slide. And I want to highlight the fact that Smith could go back the next day and realize, well, let's suppose he traded, 1 for 1. So he traded 1 orange for 1 apple, and he ended up somewhere here in the middle of the lens, just like Jones. They both are better off as a result of that trade. But when Smith contemplates the trade that he made, and if he imagines that he could go back tomorrow and also get a trade at 1 apple per orange, think of that as the price of the product in the market. The price of oranges in the market is 1 apple. I can trade 1 orange for 1 apple, he knows. Okay, and that was possible yesterday. Let's imagine it's going to be possible tomorrow too. Smith also knows that his opportunity cost of producing oranges, because he's been producing apples and oranges for years, let's imagine, he knows that he has to give up 3/10 of an apple to produce another orange. And we can think of this just casually as his cost of producing oranges. It's in terms of apples, not in dollar terms, but in terms of the other good he has to give up, his opportunity cost. Okay, well, this allows him to make a comparison between the price of the good he's producing, oranges, and trading, and the cost of producing it. And he notes that the price is greater than the cost of producing. The price at the market, terms of trade, is greater than the cost of producing it, his opportunity cost. And that implies that he can get a profit if he could produce more oranges. And given that we're imagining that Smith is indeed a profit-seeking individual or utility-seeking individual, he's going to make the calculation that, hey, if I produce more oranges and come to the market with more oranges and can trade them 1 for 1, then I'm actually going to be able to make myself better off. So this is going to inspire him to what we say or call specialization, to specialize. He's going to specialize in orange production because he's going to think he can make more profits by doing that. Now, Jones is looking at things upside down, and his focus is on apples because from his perspective, He's able to trade and get 1 orange per apple, same terms of trade as Smith did. But his opportunity cost of apples now, A, is 3/10 of an orange per apple. Okay? And so he's going to do this comparison. The price of apples in terms of oranges is greater than his opportunity cost of apples, also in terms of oranges. So for him, the price of apples is bigger than the cost of apples. And that means he can make more profit if he produces more apples. So this is going to lead him to specialize in the production of apples. In apples. Okay? Now, what will happen if they do that and come to the market tomorrow, not with 5 oranges and 1.5 apples and so forth, but what if they come to the market with 10 oranges for Smith now, because he moves down his production possibility frontier, and if he was producing at the midpoint, Smith is going to move down and specialize in orange production, which is down here. While Jones, he's going to move down and produce more apples, which is going to be right there. So if they come to the market with these individual endowments, well, then we have to create a new Edgeworth box. That's what I meant to say. It's going to look like this. And voila, it looks a whole lot like the Edgeworth box that we created originally when we gave Smith 10 oranges and Jones 10 apples. But here's where we get the gist of this particular model and the idea or principle of comparative advantage. Because what's happening here is that the Edgeworth box is growing in size. Remember, the size of the box corresponds to the total amount of apples and oranges that are available for them to consume in total. All right, but the size of the box before, when they were producing at their midpoints, their PPF, was just 6.5 by 6.5. When they specialize in the production of apples and oranges, respectively, they're able to produce 10 oranges and 10 apples. That's more oranges and more apples for both of them to go around. And that's going to enable them not to trade just a little bit, 1 for 1, and get a little bump up in Smith's utility, for example. Instead, Smith is going to be able to trade from this point all the way up to, let's say, a point like E. Don't know exactly where. It's going to be somewhere in the midpoint, and that's going to enable Smith to get to a much higher indifference curve than he could have achieved on his own in autarky without specialization. So here, what we want to emphasize is that as a result of specialization in which good? Well, it turns out to be the good in which Smith has the comparative advantage. We calculated that previously. And Jones turns out to ends up specializing in also the good he has a comparative advantage in, which happens to be apples. And when they specialize in the good in which they're relatively better at producing, we learn that there can be an increase in overall production of both apples and oranges, and that's what we mean by improvement in production efficiency. So now we've got 2 different types of efficiency defined. There's an improvement in efficiency just because you take a bundle of goods and mix them up and split them up differently amongst the 2 individuals. We learned that in the pure exchange model. And in that model, we called that improvement in efficiency consumption efficiency improvement. But now we're getting an additional efficiency improvement that comes about because of specialization, producing only the good which you're good at producing. And through specialization, we get an improvement in overall production, and we call that improvement in welfare that corresponds to that, an improvement in production efficiency. And that's an important and key result of this particular model. Okay, so we give Smith and Jones different production capabilities. We imagine they come to the market producing what's best for them independently, but we learn that if they actually seek profit, how to make more money out of the situation, that seeking profit is going to lead them to rearrange their production in a more appropriate way, meaning a way in which they can actually increase total output of the goods that they are producing. And notice, there's no increase in labor input into the production process here. Smith and Jones don't spend more time producing apples and oranges to get more. Instead, they simply rearrange who produces what, and by doing that, they get more output. Now, if we were to extend this to the real world and imagine or hope that these same conditions were fulfilled, it would be indicative of the fact that if firms seek profit and they just try to make more money in the marketplace, that they're going to be led I'll use Adam Smith's term, as if by an invisible hand, to produce the good in which they have a comparative advantage, to specialize in that particular good, trade it into the marketplace. And if they do that, there's going to be more goods to go around for everyone to enjoy. And so it's going to lead to the enrichment of everyone to which they trade with because of their specialization in their appropriate good that they produce. And that, again, is another rather surprising and counterintuitive result that I would claim most people don't understand or get to, because either they haven't taken an economics class or they have taken it long enough ago and they have forgotten this particular principle. But this is also why free market proponents are key on thinking that what firms should do, business's sole priority, is just to try to make more money. If they can make more money, it's going to improve the overall condition of everybody in society. Now, one caveat, and this is the caveat I raised last week, talked about ethical constraints in a model. These ethical constraints that I pointed out are still valid. They still have to apply. So when I say firms should make as much money as they can, and that's going to be good for everyone, it's subject to Milton Friedman's caveat, which is subject to the rules of the game. They have to be not deceiving each other, presenting good information about their products, not stealing or being willing to steal from each other. Those sorts of outcomes will not lead to this sort of improvement for everybody like we're describing in this particular model. So the outcome is contingent on certain preconditions or assumptions that have to be true or valid in the real world. And here too, we can say, oh, well, that's not valid in the real world all the time. And that's absolutely true. And so in those circumstances where it's not true, we have to take pause. But at the same time, we can look at this and say, well, wait a minute, but these conditions maybe are valid in many circumstances and at many times. And so the principle and the conclusion might actually be valid a lot of times in the real world. Okay, so it's kind of hit or miss, but what's true in the world is going to depend on the circumstances that prevail at that time.